Hello, everybody, and thank you for joining us. I'm Niall Buchanan with Broadcom, and I'd like to welcome you to our session today on the topic of ABCs of IBM Z Netview IP management. A lot of new and exciting advancements taking place, and the focus of our session today is on the management functions. If you have any questions during the webcast, please feel free to submit those through the chat window, and we'll be having a live Q&A at the end of the session. Don't forget to fill in your feedback forms and contribute to the charity. And with that, I'd like to turn things over to Pamela McLean from IBM.
Thanks, Niall. Hello, everyone. My name is Pam McLean, as Niall said. I am the Netview architect, and I'm going to talk to you about ABCs of IP management in Z Netview. So our agenda today, I'm going to cover basic enablement. In the lieu of time, I have put some of these slides in backup and focus mostly on enablement for newer functions in this area, and a particularly complex one, which is intrusion detection. We're going to talk about TCP connection management, packet tracing, discovery manager, DVIPA, intrusion detection, and I've provided a few troubleshooting slides to help you if you run into problems in this area. So the first thing we want to talk about is Netview did GA a new release in December 2019. I can't believe it's been almost a year now, but as part of that, we did rebrand. And so I wanted to include the old names and the new names for you, as well as the short names. You probably won't see the short names very much, but they do get used in places like ShopZ. Additionally, we did have our traditional level set APAR after the GA. So that APAR number is 08588819, and we did update our Netview books at that time. We also had what we called an SNMP APAR, which is 08588850. And essentially what that one was is a MIB file or two didn't get packaged at GA. And so this APAR fixes that problem. And then there were a couple of other packaging issues that were also resolved. So you'll definitely want to get those two APARs before you get started. So why do you want to do IP management? You can manage your TCP IP connections. And now with our introduction to ZIRT, you can see the security encryption levels for those connections. You can diagnose problems using real-time packet tracing. You can determine if your target distributed DVIPA servers are healthy. You can review distribution of Sysplex distributor connections. You can be informed when an intrusion occurs in your network and automate on that intrusion, discover if your OSs are active, and proactively monitor IP resources. So let's jump into some basic enablement. A lot of people say, well, there's a lot there. Where do I start? So a lot of times you need configuration in both Netview and zOS communication server. In Netview, the majority of the configuration is in a CNM style user member. The statements are in CNM style, and if you need to modify them, you copy them to a user member. There are occasionally some additional configuration members. In zOS communication server, you might need changes in your TCP IP profile, your TN3270 profile, an SNMP configuration file, and the policy agent. So depending on which options you use, you're not going to make changes in all of those areas all of the time. So on the enablement slides, as we go through, all the enablement is for Netview unless otherwise noted. So the first thing you want to do with enabling IP management is configuring the following symbols to zOS. And this is your VTAM net ID, CNM ROADM, which is our data cache for some of our network management information, the TCP IP stack name, and the Netview domain name. And these symbols are referenced in CNM style. The next primary thing is tower enablement in Netview. By default, we do enable TCP IP collect, which covers the TCP connections, packet tracing, and now ZIRT. We also automatically enable the discovery manager, which discovers a lot of resources with the main goal of being able to build you a hierarchy of these resources. And I'll show you an example of one of those hierarchies later on. We also have AON and IPMGT, which are capabilities that let you proactively monitor your IP resources. And then we also have DeViPA, which gives you everything from DeViPAs to distributed DeViPAs, your Sysplex distributors and targets. There are additional subtowers and other configuration, but these are the primary ones. Some of these functions do require SNMP, and just be aware, still to this day in Netview, there is no way to dynamically update your tower statements without a Netview recycle. So for user interfaces that we have, first of all, if you want to display information in the Tivoli Enterprise portal, you will need IBM Tivoli Management Services. It's a separate no charge orderable with a Netview license, or if you have it for other products, you don't need it specifically for the Netview piece. And so you will get the ITMS, which is the zOS portion, and then the distributed portion, which is IBM Tivoli Monitoring, will come with ITMS. You also need to get the IBM Z Netview Enterprise Management Agent, which I'll call the Netview agent for the rest of the presentation. And it is also a separate no charge orderable with a Netview license. We don't ship it out of the box because not everybody wants that. But if you do want it, you do have to order it separately. And then the Netview application support that comes with the Netview agent. One of our other graphical interfaces is the Netview Management Console. This has been around for a really long time, and this is where the hierarchical displays are done. That comes with Netview proper, and you're just going to install the server and client on the choice of your distributed boxes. So let's jump into connection management real quick. So we use the zOS Communication Server NMI, Network Management Interface, to retrieve the connection data. Active connection data is kept in Netview and zOS Communication Server storage. Inactive connection data is written to Netview vSAM datasets, and you can filter the data using CNM style definitions. With the inactive connection data, you can also purge the information on timers or however you want to manage that, because over time, those vSAM datasets are going to fill up. We also have cross-domain capabilities that enable the viewing of the connection data at remote host. And of course, we support IPv4 and IPv6. So what data do we have for active connections and inactive connections? I'm not going to go through all of this. We basically have your typical local and remote IP address and port, the stack name, things like bytes sent and received, your byte rate, segments sent and received, those types of things. We also have some information about ATTLS if it's applicable. And the main thing for inactive connections is the termination code. So if we look here, it tells you over on the far right, it shows you the reason that the connection ended. And this is very useful information if there's a problem. It might give you a clue of what happened there. So using connection management, we have a TCP-con command, which is a raw, unformatted, the output is raw and unformatted, which is basically used for a programmatic interface. CNMS TCPC is a customizable sample that the output is readable. We provide column headings and things like that. So by customizing it, you can actually remove columns, you can rearrange the order of columns, however you want to see the actual data. And then we also have the IP stat command, which is a panel-based connection control. So you can view the connection data from the Netview 3270 console or the Tivoli Enterprise portal. So connection management and ZERT. So what is ZERT? ZERT stands for zOS Encryption Readiness Technology. It's a feature of Communication Server that came about in zOS 2.3, and it collects and reports the cryptographic security attributes of TCP/IP connections. TLS, SSL, SSH, and IPsec encryption protocols are supported, And the information supplied includes cryptographic algorithms, key links, certificate data, and other security-related information. And the data can be written to SMF records or retrieved using a network management interface from zOS communication server. And it can be used for determining regulatory compliance or detecting connections with weak or no security. So this is new in 6.3. And of course, we retrieve this information from an NMI. And today we're only retrieving the SMF record 119 subtype 11, which is the detailed record. So we keep data for active connections. Data is not kept when the connections go inactive, and it's not collected for connections of less than 10 seconds duration. If the data is changed on a connection, because the security attributes can change during the lifetime of a connection, the data is updated to reflect those changes. So you can view the ZERT information from the Netview 3270 console. We have a new command called consec. And again, that's the raw, unformatted data output for programmatic use. And then we have a sample very similar to TCP/CON called CNMS ZERT, which is the customizable formatted output. We have new workspaces in the Tivoli Enterprise portal. And so on the TCP/IP connection workspace, which I'll show you parts of these workspaces in just a second, we actually have a new window that shows the number of connections per encryption protocol. And from that workspace, you can actually drill down on a particular connection, or you can go from the summary that shows the totals and look at the details about the encryption protocol. Okay, so how do you enable this? As I mentioned, there is a new tower for ZERT under the TCP/IP collects major tower, and the subtower is called CONNSEC or concept. It is commented out by default because there is a lot of data that flows with ZERT. You can also decide if you want to start this at Netview startup. If not, you can start it dynamically, that's fine. And then there's some additional statements that I've provided here that lets you do more than one stack. And you can also do some filtering with these other statements. If you want to see the security data in the Tivoli Enterprise portal, then you do need to enable the TEMA tower and a consec subtower for the TEMA. And then depending on how many connections and your volume of data, you will want to review the number of rows that can be displayed in that workspace. There's also zOS communication server configuration, which goes in the profile. And you'll need to turn on NetMonitor ZERT service and configure ZERT on the global config TCP/IP profile statement. So this is the consec command. If you're familiar with the TCP/CON Netview command, this looks very, very similar. You get to do all your filtering with this command. And so you can really drill down and just look at information for one connection if you really want to get to that level of granularity. So this provides you lots of ways to minimize the amount of data that you want to look at. Okay, so let's take a look at the type of information that we're getting from ZERT. So this is our high-level TCP/IP connection data workspace. And the new view in this workspace is down here on the bottom called the security protocol counts for active connections. And you can see here that we show you the number of connections per protocol type and how many connections have no security at all here. So if we choose a connection and we drill down on it, and this is one of the connections that has TLS, then you can see the TLS details for the connection. In this case, I highlighted that this one has version 1.1. That's fine to use if that's what you want to use. The majority of connection recommendations these days are typically TLS version 1.2 or higher. but we have other, information in here like the message authentication algorithm and things like that. So if you drill down from that view, you can actually see the TLS certificate details. And then if you drill down from this view, you can actually look at the cipher suite information that's being used on that connection. So if we look at the SSH security details for connection, you can see the inbound and outbound message authentication. In this case, these do match. They're the HMAC SHA-2 256 on both ends. So this is just an example of the types of information that's provided for SSH. And then this is the information that's provided for IPsec if you're using IPsec security on your connection. So let's move over to packet tracing now. So what can you do with packet tracing? It provides real-time capture and formatting of IP and Open Systems Adapter or OSR packet trace data. You can display unformatted packets. You can view formatted packets and see an analysis of the trace records. You can save the traces in Netview data sets. You can control multiple systems from a single Netview. And then you can save the traces in an IPCS or sniffer format, which is new for 6.3. The traces get analyzed in IPCS using the IPCS formatter tool, and I'll show you an example of what that looks like. And then you can merge traces from different systems into a single trace. And of course, you can send these trace data sets to COM server support for diagnosis. So I wanted to just show you the different packet tracing commands. I'm going to show you panel information about how to get started with packet trace, but the PKTS command provides more options, especially like if you want to start and stop a packet trace at a certain time and turn it off at a certain time, or turn it off after so many packets. That gives you a little more control than what you get on the panels today. So the PKT trace starts and stops using the Netview 3270 console. As I said, the PKTS command gives you more control. The FMT packet command lets you format the packets, and then you can list your packet trace information, your saved traces. And the way you get into this panel interface is using the IP trace command. So the packet trace and sniffer format, as I've mentioned, is new in 6.3. And so to enable this support, we provided a sample. Essentially what we're doing is sending a batch job over to zOS communication server to generate the sniffer formatted packet trace. So our sample is called CNMS JSNF. And so you'll need to update that and put it in a proclib in your data, in your environment. If you change the name of that startup procedure, then you also need to change a statement in CNM style called pkts.snfproc and put that in your user CNM style member. So if you're using cross-domain IP management to capture and save the packet traces, then you have to put this CNMS JSNF startup procedure on each remote system. And it must be the same as that needs, and the name has to be the same as on the domain, the local domain that your focal point domain, I should say, where you're trying to collect all that packet trace data. So we've also allowed you the ability to provide your own high-level qualifier for the data set that's created when you save packets. And I'll show you an example of that. So the new statement is called pkts.save_HLQ. And the default for that is Netview. All right, so let's go through a real quick example here of starting a packet trace, because that is the most unintuitive thing about using this feature. And it took me a while to figure it out. And so I always like to communicate this. So when you first come up, this is issuing the IP trace command. You're going to see that it's the packet trace is inactive, and that's from a Netview standpoint. And then you're going to see that sys TCP/DA says none, which is from the COM server standpoint. So in order to get started, you need to use this PF10 that I have circled down at the bottom to start and stop the packet trace from a Netview standpoint. So when you do the PF10, if you want to start the packet trace, then you put a 1 there and press enter. That will bring you back to the main panel, and then you will get a list of interfaces, and I've selected all here. And then you're going to start sys-TCP/DA, which is essentially you're going to issue a very TCP/IP packet trace command under the covers to zOS communication server. And now you're active, you're collecting packets. So now let's go view the packets. So you put a 3 in, and we're going to view the packets. You can change the number of packets that you want to analyze. And so if we hit PF10, we're going to analyze. And you can see from the packets that we analyzed that some of these are flagged as potential issues. I mean, definitely the red is really issues. The yellow may not be, depending on what the connection is that's going on. So if we return and we look at view packets, we're going to look at raw packets when we do this. And so this is what the raw packets look like. And the circle at the top left, I'll explain in just a minute, because if you put your cursor under one of these, then you can see the formatted packet. And then we're going to follow up with a save packets view after that. So this is what the formatted packet trace detail looks like. This is formatted by IPCS. It's all in English, thank goodness. And then if you do that save PF key, now you get a new window that pops up that's going to let you specify the ctrace formatted data set name. And we're still going to save it in the ctrace format, even if you also want to save it in the sniffer format. Now here, I have no, but if you want to create the sniffer file, then you would change that into a yes, and you can modify the data set name here as well. And so once you hit enter, then your data sets are saved. You can use those data sets, you know, to look at it in IPCS or in your sniffer tool as well. Whoops, sorry, I got a little ahead of myself there. So now let's talk about Discovery Manager. So what is Discovery Manager? Basically, it's a dynamic IP stack discovery, and we discover things at a higher level and at a lower level than just the TCP/IP stack. The stacks are detected automatically when Netview initializes or when a stack starts after the Netview program. We support multiple IP stacks. We support IPv6. And in the past, you used to have to define the stacks. But today, you can actually have them discovered dynamically, and we will dynamically update a policy file. Typically, the place you had to define them was in a member called CNMPOLCY. Now, so occasionally you will still have to do that depending on capabilities that you're using with AON or IPMGT. But if you're just using Discovery Manager and not those capabilities, you no longer have to define those. So this is the information that we collect here. Everything from the CPC all the way down to an OSA or HyperSockets adapter. And I'll show you a picture of a lot of this in just a second, but I just wanted to mention another new thing we have in Netview 6.3 is support for OSA 7S for the Z14 and Z15. This Discovery Manager information is available in the Tivoli Enterprise Portal, the Netview Management Console or NMC, and the Netview 3270 console. Okay, so this is an example of the hierarchical information I talked about. We have both a logical and a physical view. In this case, what I'm showing is the physical view which starts at the top with this EPC. And in this particular scenario, we're using a second level zOS system. And it goes all the way down to the OSA port. But the beauty of this is once you've drilled down, if you actually, from that port, if you go look at a parent view, you can see all the TCP/IP stacks and their interfaces and the LPARs that this particular OSA port is serving. So if you need to go do maintenance on an OSA, this is a quick picture of what all you're going to be impacting if you take that out. Now, if you're curious about the colors here, it's just aggregated status of all the different resources that are underneath. And so you can change those aggregation values, not aggravation ones, and determine like how many resources will make things turn different colors. You can also customize these colors to be whatever you want them to be. Okay, so let's move on to the topic of DevIPA. So we have a lot of DevIPA information in Netview to help you manage and diagnose problems in your sysplex. We have sampled information, real-time information, and historical monitoring capabilities. We have DevIPA events that help us keep the data current for you. And then we have a function called distributed DevIPA statistics. So you can view the DevIPA information at the local Netview domain, at a Sysplex Manager Netview domain. And at the Sysplex Manager Netview domain, you can see all of the DevIPA information from all the Netview domains in the Sysplex. The only information that we don't pull into a single system is the connection information, because there can be a lot of connection information, and so we don't do that for performance reasons. The DevIPA information is displayed in the Tivoli Enterprise Portal or the Netview 3270 console. This information is not in NMC because DevIPA data is more of a cluster technology and not a hierarchical technology, which is what NMC does. So for monitoring, we provide what we call DevIPA definition and status. And all of our DevIPA information is a combination of configuration and runtime. We don't have just a straight configuration view. So if you're looking at it, be aware that it's runtime. So we have Sysplex distributors, distributed DevIPA targets, distributed DevIPA server health, and we have views for healthy and unhealthy servers. We have DevIPA connection information, VIPA routing, and de-DevIPA connection routing. So the Tivoli Enterprise Portal displays sampled data, which is updated by the eventing, and historical data. If you want the historical data, you have to enable it. And if you want long-term historical data, you need the Tivoli Data Warehouse. The Netview 3270 commands and samples display real-time DevIPA information. So the eventing lets you keep your data current. Once you enable that DevIPA tower, the eventing is enabled by default. So if you don't want this, you'll need to disable it. But what it does, it gives you real-time DevIPA changes, like for a status change, if one's removed, if a target is added or removed, or a target server is started and ended. We also monitor DevIPA TCP/IP profile changes. So if an obey file comes in that changes your DevIPA configuration, we'll get notified. We also monitor Sysplex autonomics messages. So because DevIPA changes tend to come in burst, we'll delay a little bit before rediscovering the information, and you get to configure how long we're going to delay that. And we keep a list of all the systems in the Sysplex that seem like they need to change. There's an algorithm that figures that out. So sometimes it might just be 2 systems in the Sysplex. Sometimes it might be all the systems in the Sysplex that get rediscovered and your data updated. And lastly, we have something called distributed device statistics. And what this does is it collects all the distributed device Sysplex distributor and target and health information. And we calculate how many connections are getting sent to an IP address and port, and show that statistical percentage against the WLM weight to make sure that your connections are getting distributed the way that you want them to be distributed. So you can use this for problem determination or historical data. And you can start it at Netview initialization, or if you just want to use this for problem diagnosis, you can start it dynamically using the device log command. The information is written to a sequential data set, and they're treated as primary and secondary data sets. So when one gets full, we'll flip to the other one. And we put out messages that indicate the data set is switching. So we have a sample CNMS DVST that when you issue that, it's going to show you all the information in both those data sets. You can customize the number of records written to the data sets depending on how large your configuration is. And then you can actually see all this information at one Netview in the Sysplex. We call it the Sysplex Manager if you set up the configuration to do that. We don't have reports, but you can write reports against the data. And starting with Netview 6.3, using Service Management Unite, you can actually graph the connection distribution on an IP address and port basis. So this is an example of this new view in SMU. And in this particular case, you can see that the red line or NMP-IPL12 TCP/IP stack is getting more connections consistently than the other two stacks in the Sysplex. And the reason in this case is NMP-IPL12 just has more capacity, and so it's going to get more connections. All of this is managed by WLM and zOS communication server as to how these connections get distributed. And then here's another example of how Sysplex distributor is favoring a system. The outcome is similar to the prior scenario, but in this case, the device server health workspace displays the WLM weight for the target servers. And so we're looking just at device 9.42.46.85 on port 2023 here. And you can see just by the graph that one of the systems in the Sysplex is getting has a higher WLM weight than the other two. And if you look at the detail down at the bottom, you can see that it's 64 versus 30 and 31. So if we look at server health now, you can see again that that WLM weight is doubled, as is the proportional CP weight. And so this is just identifying that these bars are for the same IP address and port. And again, the reason in this case, and this is a really old slide, but the point is still true. One of the reason that the WLM weight is so high is because TIV MVS 7 is a newer machine with more capacity than the other LPARs in this particular Sysplex. Okay, intrusion detection. So with Netview, if you get an intrusion, you can automate actions using a Netview alert. You can get a message to designated Netview operators. You can send an email to somebody using our inform policy. You can issue Unix or zOS or Netview commands as part of your automation to gather more data or take action. We also have statistics that can be kept on a probe ID basis, and you can collect additional statistics and email those to security administrators. Now, I wanted to talk a little bit here about enablement of intrusion detection. This is not a new function in Netview, but you do have to match up some settings between ComServer and Netview for this. So you're going to enable one of the following towers and its subtowers. The AON and the AON.TCP and AON.TCP IDS subtowers, or the IPMGT and IPMGT.IDS. You cannot enable it in both AON and IPMGT at the same time. From zOS communication server standpoint, you need the policy agent, the traffic regulation management daemon or TRMD, and syslog daemon or syslog-D. And that's if you're using the report set type actions log. Okay, so this is CNM policy, which is the stack policy definition. So the first thing you're going to do is you're going to specify IDS auto equals yes. And if you want to specify an interval there, you can. But the main configuration member is CNMS TIDS. And you need to make a choice here. So there's two different ways Netview can monitor intrusions. We can do it via console messages that zOS communication server emits, or by pulling messages from syslog-D. So when you want to do syslog-D, then the Netview CNME Unix server must be running. And to match the specification in COM server for messages or syslog-D, in the pageant configuration file, there's an IDS report type actions of console or log. If you want the messages to come to the console and for Netview to automate on those, then you're going to choose console. If you want Netview to monitor syslog-D, then you're going to choose log. And then you're going to also configure pageant with your intrusion detection rules. So there's also an FKX CFG01 member or CNM IPMGT member that lets you configure your notify statements. And then there's an inform policy that I've mentioned here that you can specify your inform policy member and set that up to how you want people to be informed when there's an intrusion. Okay, troubleshooting. So I don't have a lot of information here, but hopefully this will be enough to get you started. And I've tried to call out some of the primary things that we've seen come in from customers into our support area. So the first thing is make sure that everything's enabled and configured. And the way to see those towers is to issue the list var command. It will show you all the towers, all the sub towers that have been enabled on your particular Netview. If something's not working in Netview, or you don't think the data is correct, issue an equivalent zOS communication server command. Because we get that data from zOS communication server, we do some calculations for the distributed device statistics, but in general, we're not making up the data. we're getting it from the ZCS. If you say, well, I can't see data in the TEP for function XYZ or X, issue the Netview equivalent 3270 command, which I have those commands in backup here, and see if the data is returned. Okay. If the data is returned for 3270, then verify that the appropriate team of subtowers enabled. And for most of this information, there's a command called COLLCTL. And if you do list info, make sure data collection is running for the different subtowers that you've enabled. And if not, you can dynamically start that without bouncing Netview. Ensure that SNMP is enabled for functions that require it. And to enable a cross-domain function for packet trace, you need to define remote sends in CNM style, which is going to allow you to communicate via remote command. And you need to define gateway operators in an EZL CFG01 member. Okay, for those functions that require SNMP, you got to get the community name matched between COM server and Netview. And that's the most common problem we see, is those don't match. So from a COM server standpoint, in your TCP/IP profile, it's sa config community, and then you specify your name, or in your TN3270 profile, it's TNSA config community. And this bullet that I've cut and pasted here from the zOS Communication Server Configuration Reference Guide basically says that the community name specified on the community keyword, it must match one in the pw.src or snmpd.conf data set used by the SNMP agent, or specified on the -c parameter when the SNMP agent is started. In Netview, in the CNN policy member, you specify the community name. If you're not using CNN policy, but you're using SNMP, because Netview has a lot of SNMP commands, you can do walks of MIBs and things like that. You can review CNN SCM. That's just a member where you can go in and put your community name. Okay, so Devipa workspace data is missing or incorrect. And this is why I emphasize that the Devipa information we have is runtime data. So we've had clients come in and say, well, this data doesn't look right to me, or I'm not seeing any data. And so the Devipa dynamic TCP/IP profile configuration statements will largely determine the data that you see, but environmental factors can cause dynamic changes in the data, such as a TCP/IP stack being taken out of the sysplex if it's not healthy enough to accept distributed Devipa connections. Okay, so here's 3 simple examples that kind of illustrate some of these points. There's no data in the Devipa application instance workspace. So what you would want to do is look at the Devipa definition and status workspace and look in the origin column for a value of range bind or range I octal. And if those values aren't found, then there should not be any Devipa application instance data. Another scenario is you've configured a distributed Devipa for IP address 1.2.3.4, but you're not seeing any sysplex distributor data in the Tivoli Enterprise portal. So again, you're going to look at that Devipa definition and status workspace. That's your configuration and live runtime data for your Devipas and distributed Devipas. In that case, you look in the status column, and if that status value is backup, you're not going to see distributed Devipa 1.2.3.4 because it's not active. Now, if that backup becomes active, you will see that active, and the Devipa that it was the backup for, you will not see when we update the information. And finally, a distributed Devipa is configured for IP address 5.6.7.8, but there's no distributor target data. You're going back to that same definition and status workspace, but then you're going to look in the distributor status for a value of target or distributor and target. So again, depending on what you're looking for, that definition and status workspace is your first stop to try to figure out what's going on. Okay, and this is a common one. I have an OSA, but Netview doesn't display it. So these are the steps here that you'll want to go through. When no output's returned, I'm going to start with the simpler case down at the bottom. Make sure that the appropriate discovery towers and subtowers are enabled using the listvar command, and make sure that SNMP community name matches in all the appropriate places. Now, if you can't see it, I'm back up at the top here, you're going to issue a command, cnms ifst as the sample, or ifstat commands to display your TCP/IP interfaces. So if you get data there and you see your OSA interface, then you know your towers are enabled, you know the SNMP agent and OSNMP is running and working, and you can see the type of interfaces that are available. So once you verify that you can see your OSA in the list, then you should be able to see the information in the Tivoli Enterprise portal. if there's no OSA interfaces, then you need to make sure the OSA subagent IOB SNMP is started. And if you're viewing the data in the TAP, you got to make sure the TEMA towers and subtowers are started. And then you also want to check your data collection command and ensure data collection is running for all of those interfaces. Okay, so that's the presentation today. So just briefly, I'm going to take you through more information. The Netview customer forum moved early this year. So this is the new link, Netview 6.3 documentation knowledge center link. And then here's some more information about the different service management and service automation suites, system automation, the Zoe project community site, and the ZITSM newsletter. I also like to include as part of this more information, Netview has a lot of books to search or figure out where you want to find something or which book to find something. So our writer has made it easy. Basically, there's a zip file with the PDFs on the Knowledge Center, and you're going to download that and extract all the PDFs. But as part of the PDFs, there's an additional .pdx file, and the PDX file is the one that lets you search the entire library. So if you double click on that, you're going to get a search window like it's here in the middle of the slide, and you can type in whatever string you want to search for. And an example is I searched for message revision table, and you can see every Netview book that it's in. And if you expand the little twizzle, you will actually see each line in each book where that phrase is. And if you click on a line, it's going to open the book for you and take you right to that location. Okay, so this is backup. I'm going to go through this real quick. You can use this for reference material. There's more configuration information and some commands in here. And I want to say thank you very much for attending today and listening. And please submit your session feedback. This is the information for this session number 6BE. The slides are uploaded, so you can get those. And also wanted to say thank you, if you can, for giving to the GSE UK Conference 2020 charity. So thanks again. So Niall, back to you.
Have we got any questions, folks? For Pam? No, doesn't look like. One from me, the sniffer trace, what's the format of the output file? Do you know?
I mean, it should be able to be viewed with like Wireshark or anything like that. You have to download it to wherever you have your sniffer tool, okay, to be able to view it.
Thank you.
Okay. Are there any questions in the chat? I can stop sharing here.
No questions in the chat yet.
Okay.
Okay, if there are no questions, we'll close the session down. Don't forget to fill in your feedback form, and please contribute towards the NHS charity. Got a thank you from Stephen. Thank you. Thank you for attending.
Yes, thank you very much, everyone. If you have questions, feel free to email me directly.
Okay, I think we'll end the session now. There's no further questions.
Okay, thank you, Niall.
Okay,
have a great evening.
Thank you, Pam. Thanks very much, Pam. Cheers.
Bye-bye.
Bye.